Hello everyone, here we are to construct an example of a non-deterministic finite automata to represent a particular language that doesn't contain BAAB as substring. In order to create an NFA that doesn't contain a BAAB as substring, we need first to create a transition table that accepts BAAB. So in Q0, when I see a B, I'm gonna go to Q1. And in Q1, when I see a A, I'm gonna go to Q2. And in Q2, when I see a A, I'm gonna go to Q3. And in Q3, when I see a B, I'm gonna go to Q4. So Q4 is the final state of our language that contain a BAAB substring. Now, in order to create a NFA that doesn't contain a BAAB as substring, the Q4 on the transition table, we're gonna remove it. But remember, in NFA, we don't need a dead state. We just make it null. Or we don't need to make a pathway of an alphabet. So in B, at Q3, we don't need it. So the states that we need is Q0, Q1, Q2, and Q3. And every B in Q0, I'm gonna go to Q1, and Q1 A, Q2 to Q3 A. So these states are very important to create NFA that doesn't contain a BAAB as substring. Now, we're gonna make a transition table that doesn't contain a BAAB as substring. So remember the flow BAA. So in Q1 at Q0, the B is gonna go to Q1, and in Q1, the A is gonna go to Q2, and in Q2, the A is gonna go to Q3, and Q3, there will be no more B. So I gotta put it null. So how about the A at Q0? We can repeat itself. So in every Q0 and every A at Q0, it just repeats itself. So it's gonna stay at Q0. And in Q1, and I see a B, I'm gonna stay at Q1. And in Q2, when I see a B, I'm gonna stay again at Q1. And in Q3, when I see A, I'm gonna go back to Q0. That's our transition table of a language that doesn't contain a BAAB as substring. Now we're gonna make a transition diagram. Q0, Q1, Q2, and Q3. In Q0, when I see a A, I just gonna stay at Q0. When I see a B, I gonna go at Q1. And when I see a A at Q1, I'm gonna go to Q2. And in Q1, when I see a B, I'm just gonna stay here at Q1. Oops. And Q2, when I see a A, I'm gonna go to Q3. And the B at Q2, I'm gonna go to Q1. Oh. And in Q3, the B is ignored, while A, we're gonna go to Q0. This is our transition diagram of the NFA that doesn't contain a BAAB substring. Now we need to define now. To continue to define our NFA, we need the number of states. How many states that we need? That we use? Q0, Q1, Q2, and Q3. So the number of state is 4, and it is 0, 1, 2, and 3. Our initial state is Q0. And our alphabets are A and B. Our final state, remember that we only reject a language that that contains a BAAB substring. So everything that doesn't contain it, we can accept it. And we see that in A0230 and B111, it can be accepted. So Q0, 1, 2, and 3 are our final states. So we're already done at defining our NFA. Now we're gonna create our regular language of this NFA. At Q0, A can be multiple. So we're gonna write A star. At Q1, B can be multiple. So you're gonna write again a star, B star. Q1 to Q2 have A, but Q2 can be B. So when Q2 is B, he's gonna go back to Q1, and Q1 is multiple B. So B star. And when Q2 A go to Q3, A, but Q3 is to Q0 is A, and Q0 is multiple, we're gonna add a star. So this is our regular expression of this language. A star, B star, A plus A, B star, A star. Hope you learn. I hope you enjoy.